it's about the journey, not the destination. Okay, just kidding. Anyway, let me introduce the evolution of the extension board I made for the self-balancing scooter. When I had started working on the first version, I had a limited knowledge and limited parts as well. I didn't have logic level converter, neither voltage regulator. I only had some relay with one Arduino kit. And the original idea was in the first version that using the relay to power off the original gyro board and use information from external information to control the main board. This version has a quite ugly design. Let me show you the other side. As you can see that I have headers in the other side, and the soldering looks a bit ugly. And I made this ugly design with this soldering iron, but it's practically cheap but useless. It's just waste of time. I don't recommend anyone to touch something like this. Alright, so when all the parts arrived, I almost tried, but I could not try because it's overheated, the voltage regulator, so it's turned off by itself. What is nice from this, but practically it leave me without any power, and I had to redesign the first version. And meanwhile I was able to check the voltage logic converter, and it's turned out that it's also a bad idea. So when I start working on a second version, what I replaced the voltage regulator with the DC-DC step-down module, and I completely ignored the logic level converter. So I just I just lead the pin out, and I designed the way that what I plug here will be responsible for the logic. So practically it will care about less logic, but should be able to work at least. So it was not designed for the final version, but to help me to speed up the development. But with this I was able to get some result. What was terrible, the relay logic, it's practically just doesn't work. I should not turn off and on the gyro board because it made the scooter jumping around, and so this version 2 was practically not satisfactory. When I started working on the third version, I implemented a multiplexer logic with this 8 piece of transistors, basically not gates, and this was the first version that started working, but it was quite complicated. So here we have the schematic view, and practically it was able to communicate with the main board, send signal to the main board, but it has no information of the status of the wheel. What is turned out is quite important, because the board has two ways of the communication. When you step on with one foot, it's the degree of your toe tells the speed, but if your both foot is on the board, practically the degree is just acceleration, and if you don't know about the status of the wheel, the acceleration is quite useless. So in some certain senses, this board, this extension board can work, the version 3, but it's all. I needed more information about practically I wanted to control the speed. Don't let the speed goes the maximum without any control. So in the fourth version, I practically replaced the logical gate what I built manually with the multiplexer, and I also implemented the Arduino Mini already in the extension board, because the Arduino, because it's quite complicated to connect to the system. So the first version is I just hijack the cable between the gyro board and the main board. But in this version, I also need to receive information from the halt effect sensor as well, what is implemented here. So practically there is many information, and this Arduino Mini have to read the wheel signal and have to send the information back. The software is not done yet, but practically no need to be done, because these pins here will be lead out to a connector, and these pins are responsible for serial communication, so I can upgrade the Arduino code without playing with the soldering and anything here. And this P2 I2C signal I can put here, I2C wires as well, so I can control two different way without bothering the solder on and off. So right now this is not tried yet, but according to my expectation, it should do the job, and I hope it will work well. A little bit here of how it works. So practically the Arduino mini board here, it has the halt information, it has I2C buses, a very minimal logic, not logical, not gates, but help me in the communication from the Arduino to the main board. So the signal came from the Arduino board, or it came from originally from the gyro board as well, and it's go to the motherboard. So it's quite simple logic compared to the version 3, but it's because I implemented the Arduino mini board as a daughter board. I expect it will work well. Let's see.